Hello everyone. So, Today we are going to see a topic about hypothesis spaces, inductive bias, generalization, and bias variance trade-off. So, these concepts help us understand how machine learning models learn from data and how to build models that make accurate predictions. So, in machine learning, so many techniques are available. So, every concept, the main goal is prediction. So, prediction. So, if we have the 100 data, so how we predict, how the model going to predict the 101 data. So that is the machine learning. So first, why these concepts matter. So first of all, we are going to see. So in machine learning, models learn patterns from data in order to make prediction or decision. So however, choosing the right model is very important because we can in ML so many models is available. So but we have to choose one model. So, however, choosing the right model is very important. Concepts like hypothesis spaces, inductive bias, and generalization help us design models that perform well not only on training data but also on unseen data. So, what is hypothesis spaces? So, in this definition, the hypothesis space is the set of all possible functions or models a learning algorithm can select from. It defines the search space for the optimal predictor. So, for example, a machine learning algorithm may choose linear equation, decision trees, or neural networks to solve a problem. A larger hypothesis spaces provides more flexibility, but it can also increase the complexity of the model. So that's it. So next, representation of hypothesis spaces. So in this slide shows the mathematical representation of the hypothesis function. Here, X represent the input data, Y represent the output. So and H of X is the predicted result. During training, the learning algorithm searches through the hypothesis space to find the hypothesis that best fits the data. So you can go through this diagram also. So next, inductive bias. So inductive bias refers to the assumption a learning algorithm makes while learning from limited data. For example, many algorithms assume that similar models are better because they generalize more effectively. Without inductive bias, machine learning system would not be able to make predictions for unseen example. So generalization, next slide is we are going to see generalization. So generalization is the ability of a machine learning model to perform well on new unseen data. So ability is the key for in the generalization. So a model with good generalization gives accurate predictions not only for training data but also for testing data. The main objective of machine learning is to learn meaningful patterns rather than memorizing the training example. So next, overfitting and underfitting. So overfitting happens when a model becomes too complex and memorize the training data. We already seen in the previous topics. So such as models perform poorly on new data. Like overfitting means the performance is very low. So underfitting occurs when the model is too simple and fail to capture important patterns. So that time the underfitting is happen. So a balanced model should avoid both overfitting and underfitting to achieve good performance. So I hope you understand this concept. So you can go through the diagram also. If you if you want more clarity, you can go through this. So next, the bias variance trade-off. So bias variance trade-off, we one formula also is that total error equal to bias square plus variance plus irreducible error. So the bias variance trade-off is one of the most important concept in machine learning. Bias refers to the errors caused by overly simple assumptions, while variance refers to the errors caused by excessive sensitivity to training data. A good model maintains a balance between bias and variance to minimize overall prediction error. So the next is importance of machine learning. These concepts are essential because they help improve model selection and prediction accuracy. They are widely used in neural network, regression model, and classification system. Understanding these ideas helps data scientists build reliable and efficient machine learning application. So next, finally, we are going to the conclusion. To conclude, hypothesis spaces define the possible models a machine learning algorithm can use. So inductive bias guides the learning process. Generalization measures the performance on unseen data, and the bias variance trade-off helps achieve optimal model accuracy. Together, these concepts form the foundation for building effective machine learning system. So I hope you understand this concept. So if you want any clarity or if you have any doubt, you can put in the chat box. So thank you.